Okay, our lesson today is solving two-step inequalities. This is probably a review lesson for most of the honor students, but we're going to move a step farther today and really look at math in the real world. How do we use this in the real world instead of just on a worksheet? So first we're going to just review the process in which they're solved. The word inequality. When you hear the word inequality, I wonder what words come to your mind or what you think of. Inequalities are different than equations. In the equations, you have an equal sign. And when you have an equal sign, your answer is saying that there is one solution. Inequalities means that there is going to be a range of numbers that could be the right answer. And a lot of times in the real world, the answers are not exact, but there's a range of numbers that would be appropriate. We're going to look to see how that is so. But first, real quickly, let's just review the process that we go through to solve inequalities. And it works just like two-step equations with a couple of extra rules you have to remember. So in our first example here, 3x plus 2 is less than or equal to negative 7. Our goal is still to get x by itself. So our first thing to do is to move the 2 to the other side of the equation using inverse operations. So we subtract 2 on both sides. When we do that, the 2's cancel out because a positive 2 and a negative 2 make a 0. We have 3x is less than or equal to negative 9. Final step is divide both sides by a positive 3. 3 divided by 3 is 1. So that becomes invisible, and we have x is less than or equal to a negative 3. Now, a sign is very important. You have to look for whether it is less than and equal to, or equal to. Because it has the line underneath it, we know that the solution could be a negative 3. So to show this range of numbers that could be the possible solutions, we graph it on a number line. We go to negative 3 on the number line, and we're going to put a what we call a filled-in dot to indicate that it could be negative 3. It could also be any number less than negative 3, so we indicate that by putting an arrow going to the left. In our second example, which works exactly like the first one, we begin by subtracting 160 on both sides of the inequality. That leaves us with 4f is less than or equal to 340, if my mental math skills are on target today. Next, we want to divide both sides by 4. And that would give us, I believe, 85. Here, let's see. Yes, f is less than or equal to 85. Again, it could be equal to 85, so when we graph it, we put a filled-in dot to indicate, yes, the solution could be 85, but it could also be any number less than that, so we draw the arrow to the left. Now, you may have learned a rule before about looking at the inequality sign to help you know which direction the arrow goes on the number line. This works if the variable is on the left side of the equation. If the variable is on the left side of the equation, you can look at the inequality sign and it shows you the direction that the arrow is going to go when you graph it. If the variable is on the right side of the equation, everything will actually be flipped. Notice over here that the greatest part is facing the 85, so when we do it over here, the greatest part has to be facing the 85. When the variable is on the right side, the arrow does not go in the same direction. That does not work. So if you've learned that rule, it's great. Just remember that the variable has to be on the left side for the arrow to go in the same direction. In this example, there's an additional rule that we have to remember. We're going to add 5 to both sides of the equation first. 5's cancel out. We have negative 12x is greater than a negative 72 when we are multiplying or dividing by a negative number. In this case, we are dividing by a negative 12. Because that is dividing by a negative 12, we know that we have to flip the sign. So x is less than 6. You solve it, but you flip the sign. Now this one does not have the line underneath it, so this one reads x is less than 6. So the solution is not 6, it's every number less than 6. So when we graph it, we do what we call a circle dot. And we do not fill it in to show that it's not 6, but then we draw this arrow showing that it's any number less than that. So the rule, when multiplying or dividing by a negative number, you must flip the sign to make it correct. Let's try one with fractions just to make sure we remember the rules with that. We're going to start by subtracting 5 on both sides of the inequality. We have negative 1/16 x is less than negative 6. We have x being multiplied by a fraction, so we need to divide by a fraction. But we have learned that when dividing by fractions, we actually multiply by the reciprocal. So we're going to multiply both sides by a negative. Notice the negative sign. When multiplying by a negative, there's an extra rule we have to remember. Multiplying each side by negative 16, these create a 1, so you're left with 1x, so the 1 is invisible. It was negative, so we flip the sign, and then 16 times 6 is a positive 96. So x is greater than 96. This time we have a circle dot on 96 and an arrow to the right. Now, how do we use this in the real world? Let's look at a few examples. And we're going to read, translate it into an equation, and then solve it. First example, the average of Jim's 2 test scores must be at least 50, or I'm sorry, at least 90 to make an A in the class. Jim got a 95 on his first test. What score can Jim get on his second test to make an A in the class? To write the equation, we have to pause and say, okay, how do we find the average of grades, or the average of any numbers? We remember to find the average, we have to add the numbers together and divide by that many. If we look up here, we're talking about 2 test scores, so we're going to be adding 2 numbers together. We know that on the first test, he got a 95. We are going to add that to what he made on the second test. Well, that happens to be our unknown because that is what the question asks for. What did he get on his second test? So that's our unknown number that we fill in with the variable. We need to add these 2 numbers together and divide by 2 because there are 2 numbers. Now, we want this score to be at least enough to get him an A in a class. 90 is an A. Now, can it be higher than 90? Could his average be 92? Could his average be 96? And him still get an A in the course? Of course, the answer is yes. So our answer is not an exact number, but a range of numbers. But we want this, which represents his score on the second test, to be at least, but it could be higher. So we're going to use the greater than or equal to sign. The score could be equal to or greater than this number in order for him to make an A. Now, when you have a fraction or division bar, it changes the order of operations. We want to get rid of this denominator first. Since the binomial on top is being divided by a 2, we multiply both sides by 2. 2 divided by 2 is 1. That becomes the invisible 1. We're left with 95 plus x is greater than or equal to 180. One step inequality left. Subtract 95 on both sides of the equation. We discover that he needs to make at least an 85. So this says x is greater than or equal to 85. He could score an 85 and have an A in the course, or he could score any score higher than an 85. A range of numbers. In our next example, we have Marcus, who has accepted a job selling cell phones. He will be paid $1,500 plus a 15% of his sales. We call that a commission when you make a portion of a percentage of what you sell. It's a commission, 15%. He will need to earn at least $2,430 to pay his bills. Now, is it okay for him to earn more than that and to have some money left over? Absolutely. So this is not an equation with an equal sign. We use an inequality sign to show that he could make that amount or more. Let's think about the equation. He will be paid $1,500 plus 15% of his sales. We turn the percent into a decimal. Now, the amount of sales is the unknown that we're looking for because that's the question. For what amount of sales will Marcus be able to pay his bills? So we're going to say 1,500 times X, which is 15% of his sales. The amount he earns needs to be greater than or equal to the amount of his bills. It's okay for him to make more, but he needs to make at least that to pay his bills. Okay, now we have a two-step inequality. I'm just going to flip through here. Subtract 1,500 on both sides. That gives you 1,500 x is greater than or equal to 930. Divide both sides by 1,500s, and we see that he needs to make at least, he needs to sell at least $6,200 worth of cell phones. Now you may look up there and say, well, that doesn't really make sense because you said his bills were only $2,430 and now he's making $6,200. Remember, this was not the amount of money that he's making. This is the amount he must sell in cell phones so that when he makes his 15% commission off of that amount, plus the original 1,500, he will have enough to pay the bills. Inequalities used in the real world.